Hi, welcome to Math for All, where everyone can learn more about math. I'm glad you're here. Today, we're going to learn an application of those radicals that we've been studying, the Pythagorean Theorem. Now, don't be scared by that fancy Greek word. This is a very famous and beautiful rule about the sides of right triangles, and square roots play a big part of it. We're going to review a little about triangles, define the legs and hypotenuse of triangles, introduce the formula, and then do some examples using the Pythagorean theorem. So let's get started. First, we must recognize that the Pythagorean theorem is only useful when we have right triangles, which are triangles with one right angle, usually indicated by making a small box in the corner. So, when we have a right triangle, the sides touching that right angle are called the legs, and the diagonal across from the right angle is called the hypotenuse. Fun fact, hypotenuse is a Greek word meaning to stretch, because it extends to reach the ends of those legs. The hypotenuse is always the longest side of a triangle, so even if they don't have a picture and they give you the side lengths, you know that the hypotenuse is always the longest side. Now, to the real stuff. Pythagoras, a Greek philosopher, came up with a relationship between the legs and hypotenuse of every right triangle. One leg squared plus the other leg squared equals the hypotenuse squared. We write this more simply by making the legs A and B, but it doesn't matter the order of those, and the hypotenuse is C. We get A squared plus B squared equals C squared. Lovely, poetic, and oh so handy. Enough Greek, let's get to numbers. We'll find the length of the hypotenuse of this right triangle that has legs of 3 and 4. Remembering our equation, A squared plus B squared equals C squared. My legs are 3 and 4, for 3 squared plus 4 squared equals C squared. 3 squared is 3 times 3, which is 9, plus 16 equals C squared. 25 equals C squared. Here's where our square roots come in. C does not equal 25. C squared does. So we take the square root of 25. What number times itself equals 25? 5. The length of our hypotenuse is 5. This brings up an important point. There are a few right triangles that the sides come out as 3 whole numbers called Pythagorean triples, and 3, 4, 5 triangle is one of them. You will see that one a lot. Okay, one step forward with this. Find the length of side X in simplified radical form. First, we notice that we have a right triangle with a missing side, so we will be using Pythagorean's theorem. The legs of this one are 6 and 10, and the missing side is a hypotenuse. We'll set up A squared plus B squared equals C squared. 6 and 10 are A and B. For 6 squared plus 10 squared equals C squared. 36 plus 100 equals C squared, which equals 136. To find C, we take the square roots of both sides. So C equals the square root of 136. To simplify this, we'll use a factor tree. 136 is 2 times 68. Then the 68 breaks up into 2 times 34, and 34 is 2 times 17. And 17 is prime, so that one's done. I see 2 2's to circle and pull out. So one of those 2's goes on the outside, and the leftovers are 2 times 17, or that 34 stuck under the radical, for an answer of 2 root 34. Finally, we'll solve for a leg and see a common application of our equation. A rectangle has a side of 5 and a diagonal of 13. What's the other side length? To start this one, we'll draw a quick sketch so we can see what's going on. Rectangle with one side of 5. Draw the diagonal and label it 13. Notice that we have created 2 right triangles. We'll use one and our formula. 5 squared plus B squared equals 13 squared. For 25 plus B squared equals 169. To solve for b squared, subtract 25 from both sides, for b squared equals 144. Square root both sides and b equals 12. So the missing side is 12, and we have found another Pythagorean triple in 5, 12, 13. Nice work in applying our square root knowledge and learning the Pythagorean theorem. Remember, a squared plus b squared equals c squared, and all will be well. I look forward to seeing you soon so we can learn more about math.